Hello everyone! In today's lesson we're going to be solving linear equation. I am Mrs. Pagan. Let's get started. Alright, in example 1 it says solving an equation with one variable on one side. So as you can see, x is the variable and it's only on the left side of the equation, not on the right. So in a problem like this, the goal is to get x by itself. So I'm going to make that green so we know. And what we do is we try to get things further out first. So we use actually the order of operation backwards. So we know that we kind of have to start here and then move up as we're solving these equations. Well, I asked myself, is there an addition or a subtraction? And I see an addition of 8 happening. So to move it to the other side, we subtract 8 to the other side. And we end up getting 2 9s times x. Positive 8 minus 8 cancels out. We have an equal sign, and we have 16 minus 8, which happens to be 8 as well. Now the last thing I see is a multiplication of a fraction with the variable. So I'm going to go ahead and multiply by its reciprocal. So the reciprocal of 2 9s is 9 over 2. I'm going to go ahead and multiply that on both sides. Well, on the left side, 2's cancel because there's one on top, one on the bottom. Same with the 9s. And x equals, I like to make 8 the fraction as well by putting it over 1. And so I do 8 times 9 is 72, all over 1 times 2, which is 2. And when we divide these two numbers, 2 goes into 7 3 times with the remainder of 1. 2 goes into 12 6 times. So x equals 36 is our final answer. Now, if you ever wanted to just check this answer, what you would do, so this is the checking part, is you would take the equation that we have from the beginning, and we would just substitute in 36 for the x. So I'm going to replace x with 36 plus 8 equals 16. I am going to make this a fraction, so 2 times 36 is 72 over 9 plus 8 equals 16. Well, 72 over 9 is 8, and when you add it to 8, it does equal 16. Therefore, 8 plus 8 is 16, and yes, that equals 16. That's how you check. When the numbers are the same, that means you have done it correctly, or when the statement is true, you have done it correctly. Alright, let's go on to example number 2. It says solve an equation with a variable on both sides. So as you can see, you have an n here, and you also have an n right there. So what we want to do is we want to combine and get those n's together. So since they are both positive, I would have to make them opposite sign, which is negative, to move them to the other side. Well, I don't want to move 12n's to the other side, so I'd rather just move 4. So I'm going to go ahead and subtract 4n to the other side. If you did it the other way, you would not be wrong. 12 minus 4 is 8. Let's not forget the n. Bring down the negative 3 equals 4n minus 4n cancels out, and we're left with positive 21, which we don't have to write the plus, we just write 21. Now this has become the same problem as example number 1. We're going to go ahead and do the opposite of 3, so we're going to add 3 to the other side. So we're using the order of operations backwards. Subtraction is gone first, so we have 8n equals 24. Last but not least, divided by n on both sides, and n equals 3. Great job. Once again, we can check our answer by substituting in the variable. You'll be doing that quite a lot in class and on exams, so you get 100%. Alright, give yourself a round of applause for doing a great job. Alright, let's go into example 3. This is a distributive property. Basically what you'll notice is the big difference is there are parentheses with numbers in the front. So we're going to go ahead and use distribution to start the process. So first thing we do is distribute the 5 to the p as well as the negative 2. We end up getting 5p minus 10 equals. Now on the other side we have another set of parentheses, So we're going to have to distribute negative 4 to the p as well as the 7. So we're going to get negative 4p. Well, negative 4 times 7 is negative 28 plus p. Now, I do notice we have a lot of p's, so I'm going to start condensing some of them. So 5p minus 10 I'll leave alone because I can't combine those two numbers. But on the right side of the equation, I have negative 4p plus 1p. So that will result in negative 3p minus 28. Once I have a p on both sides, this becomes very similar to example number 2. Now I'm going to go ahead and do the opposite, 3p to both sides. 5p plus 3p is 8p. I'm going to bring down the negative 10, bring down the equal sign. Negative 3p plus 3p cancels out, and I'm going to go ahead and bring down the negative 28. Now, this has become example number 1. We're going to go ahead and use order of operation backwards by adding the 10. Negative 10 and positive 10 cancel, but most importantly, we have an 8p left. Those I had already canceled. Equal sign comes down. Negative 28 plus 10 is negative 18. And last but not least, we're going to go ahead and divide by 8 on both sides, and p equals negative 18 over 8. Now I'm noticing that we have a 2 in common, so I'm going to go ahead and simplify this to negative 9 divided by 4. If you divide top and bottom by 2, you do get this to be simplified a little bit more. Alright, great job. I think we have 2 more problems left, so you're doing awesome. Let's look at an example with fractions. A lot of the times people get scared because there are fractions here. So let's kind of look at the number that maybe can get rid of these fractions. Well, when I think of 3, 5, and 10, these are the denominators of my fractions. I think of the number 30. That is the number that they all have in common. So if I were to multiply these, they all have that in common. So what I'm going to do is multiply each one of these numbers, to be fair, by 30. My goal is to get rid of the fractions. So here's 2 over 3 x plus 30 times 1/5 equals 30 times 2x minus 30 times 3/10. I literally multiplied right now everything by 30. And I'm going to just keep those things that they have given me in the equations, in the original equation, in parentheses. Alright, so this is a fraction, so I'm going to go ahead and just put this over 1. Put this over 1. This one isn't, so I'm not going to do that one, but this one as well, the last one. Alright, if I look at this, I'm going to change my color really quick. Bear with me so that you can kind of see it. What I'll see is 30 divided by 3. So I can simplify this right away, which some of you will say that's a 10. But what I'm going to do is kind of continue. I'm going to do 30 times 2 is 60. 1 times 3 is 3x. Plus 30 times 1 is 30. 1 times 5 is 5. Equals 30 times 2 is 60x. That's the only one that doesn't have a fraction, which is awesome. 30 times 3 is 90. Divided by 1 times 10 is 10. Now hopefully you see, wait, those numbers could be simplified very nicely. 60 divided by 3 is 20x. Now the fraction is gone, notice that. Plus 30 divided by 5 is 6. Once again, the fraction is gone. 60x didn't even have a fraction, which is awesome. Minus 90 divided by 10 is 9. Notice that now we are doing exactly the same thing we did in example 2 with just 2 variables on each side. So instead of moving the 60x, I'm going to go ahead and move the 20x because it's just smaller. No really good reason other than that. So subtract 20x on both sides. Well, 20x minus 20x is 0. So the 6 comes down. Notice I didn't bring the plus because everyone knows it's plus if I don't put a negative there. So 60 minus 20 is 40x minus 9. The goal, once again, is to get x by itself. And here's x. So I'm going to get rid of 9. And the only way I can get rid of 9 is by doing opposite. So I'm going to add 9 to both sides. So 6 plus 9 is 15. I'm going to bring down the equal sign, bring down the 40x, and negative 9 plus 9 cancels out to be 0. Last but not least, divided by 40 because I'm trying to get x by itself, and we end up with x equals 15 over 40. Now I do recognize that 15 and 40 have a number in common, and I believe that's 5, so I'm going to divide top by 5, bottom by 5, and that should help me simplify. 15, oh, I should put it on the other side. Hold on. I don't want you to get confused. So I'm going to definitely put it on the other side, or else we do end up getting fractions. So we're going to have 15 divided by 5 is 3, and 40 divided by 5 is 8. So the simplification of that fraction is 3/8, and that's our answer. All right. I just want to say you guys are doing an amazing, amazing job. Last one. Example number 5, it says, writing and using a linear equation. It says a car salesperson base salary is $21,000. What base salary means is that's what they get every year. Whether they sell anything or not, this is guaranteed. Okay, this is every year they're going to get this, regardless of what they do. And they earn 5% commission on sales, so we have 5% commission. Quick review. In math, we don't use percentages in the equations. What we use is the decimal of this, so we actually move the decimal place, remember, twice to the left. We get 0.05 is going to be our commission. And then it says, how much must she sell to earn $65,000 for the total? So she wants her total to be $65,000. All right. So this commission is the only thing that's based on something, and this is based on sales. Okay, so keep that in mind. All right, let's talk about it. She wants a total of $65,000. That's her end-all be-all. Well, she's making $21,000 regardless of what she does. And then when she sells her commission, whatever she sells, let's say she sold $100,000 worth, she's only going to get 5% of that. So we can go ahead and do 0.05 times the sales she makes. This is the sales. Okay, so I'm going to go ahead and just kind of figure out, I guess, what is the sales, because she says how much does she sell. That's what we're trying to figure out. So we're going to do simple math. This ends up becoming the equations, and we're solving for sales. So first thing you would do is subtract $21,000 on both sides, because remember we're trying to get sales by itself. Well, 65,000 minus 21,000 is going to be $44,000 equals 0.05 times the sales. And last but not least, divided by 0.05, 0.05, and we are going to get the sales equals. Alright, go ahead and type this into the calculator, and we'll go over this first thing tomorrow. Have a great day. You guys did awesome today. See you tomorrow.